right. Hey everyone, Jeff Cote here with the Pacific Yacht Systems. I want to thank everyone for spending some time on Sunday here with me to geek out a little bit about marine electrical and electronics. I feel like this is my first time to be a newscaster here. Thank you for everyone for being here. By the way, we're also now naming our channel boatingtechtalk.com, trying to be more representative of what we're talking about. We're talking about boating, so people that actually get out in the water and do stuff with their boats, as opposed to some of us that have the boat and they don't really use it. So for us that actually want to go out boating and want to be using our boats, that's boating. And we're talking about the technology on boats and specifically electrical and electronics. A little bit about myself. I'm Jeff Cote with Pacific Yacht Systems. Avid boater. Boating is my life. And today I'm going to be sharing my passion about solving problems on the water. Solving problems on the water. The other thing too, I've got a sailboat, by the way, for some of you who are interested, a 36-foot sailboat, a Catalina 36. Bought her on April Fool's Day, 2006. And let me tell everyone, I share this all the time. The beginning wasn't easy. I call it my personal Everest journey. It's boat ownership is hard. It's not easy. We deal with probably over 1,000 boaters a year here at Pacific Yacht Systems. And what I tell them is you want easy for vacation, rent a hotel room. You want easy, go to an all-inclusive. But, you can't talk about your vacation as much in an all-inclusive as you can to spend a week on a boat. Doesn't matter if it's power sail. It's going to be, as we know, potentially the best week of our lives on the water. It's just a special place. So today we're going to talk about our passion of making sure our boats are reliable and safe when we're on the water. By the way, for some of you that are curious, we've got over 1,300 web pages on our website, specifically just for information. If you're geeking out and you're curious and you want to know more, we're over probably 275 videos now, 400 Ask PYS questions, and over close to, I think, 200 and maybe almost 300 printed articles that we've printed over the years and that we've published. So there's a lot of content on there for you to geek out and educate yourself so that you can make your boating experience better. All right. So we're going to start off with a question that we had asked a few times by a lot of our avid fans on YouTube. And the first question that we're going to start with is battery boxes. So what's the purpose of a battery box? And Jeff, how do you install properly a battery box on the boats that Pacific Yacht Systems works on? So the purpose of a battery box is specifically for a flooded lead acid battery, right? So an AGM lead acid battery, also lead acid, but the electrolyte can't leak. So with a flooded lead acid battery, what you generally see on a lot of boats, and this is, by the way, not good. So this would not work for flooded, but you'll see this a lot. You'll see batteries in a tray, right? A tray like this. The tray's got little sort of holes. You put it down. You see that on a lot of boats, actually. A lot of power boats are going to do this. They're going to put this on either side of the engine room, and they're going to put the starter batteries in here, and they're going to put a battery strap. Challenge is the lip, right? Look at this lip. I mean, this lip is it's over a centimeter, not an inch. And effectively, the electrolyte is not going to stay contained here. Yeah, absolutely. If you were in a world that didn't move, a little bit of electrolyte spilling would actually maybe fill a little bit of that tray. But remember, there's also a battery in here, so there's not that much space for extra liquid. And the problem is the moment you leave your marina, your boat is not flat. I mean, if it was always flat, the world would be very different. Boats move around and electrolyte can leave the tray. So whenever we see a tray with a flooded lead acid battery, we're like, negative, no go. And so we'll tell the owner, maybe you want to go with an AGM that is not spillable, or if you're going to stay with a flooded lead acid battery, then the next step is to go with a battery box like this, right? Now the challenge with these battery boxes, as you can see, they actually don't come with any way to fasten the battery box, right? So there's no holes, there's nothing. So how does one go about actually holding down this battery box? The battery boxes like this are going to have little straps that you can mount on the side, but it's not really secure. So what we end up doing in a lot of situations is we're actually going to buy an angled aluminum like this, and we'll drill little holes. And then what we're going to do is we're actually going to make a way for the battery to actually not have any lateral motion. right? So what we're doing is we're trying to stop the battery from moving sideways. And then what we do is we take a strap to hold the battery down. So the battery can't go up a little bit, because sometimes we do go airborne on boats. It's not something that anyone wants to do, but the waves can be pretty steep, and sometimes it feels like your boat is falling. So this is a battery box. Now, the challenge is most of you are going to have these battery boxes on board, and the previous owner or the installer didn't know how to install it. And so what they did is they actually probably drilled 4 holes in each corner of the battery box. He did the whole purpose of a battery box, which is to be a container. They didn't know. And effectively, it's just a box now, but it's not a liquid type container. So it really only gives you a partial benefit of a battery box, which is to have a lid so that you can't do an accidental short between the positive and negative terminal leads. Battery boxes go bigger and bigger inside. This is actually a battery box for 2 golf carts side by side. You can buy battery boxes like this for 4 golf carts. And you can also buy them for L16s, which are a little higher. So you can buy battery boxes for individual sizes, and for golf carts, which is a very popular battery size, you can actually buy these boxes for dual, side to side, along the long side, or even for 4. So same thing with this battery box. If you've got one on your boat, a lot of times what's going to happen is people are going to actually drill holes in the bottom, and that's a big no-no. Again, it doesn't make the container liquid tight. And then what we're going to do is we're going to, again, use the angle iron, put it against the edge right here. And then that we're going to stop the battery box from moving laterally. The next thing that I do, because I'm a geek, is then I use these sort of heavy duty pad eyes. And I'll put them at either end of the battery box like this, right? So right here on the ground, imagine. And I'll have a heavy duty strap, a cargo strap. Like, I'm going to go stupid. I'm going to go, because I'm a sailor, I'm always thinking about this worst case scenario that I've never lived, but you hear about, where you've got a knockdown, and now your boat is actually not upright, it's actually sideways or inverted. And I'm thinking, I want under no circumstances those batteries to ever move around in an engine room or on a boat. The last thing you need is something weighing 60 pounds, which is, I don't know, let's call it 25 kilograms or something like that, moving around in your boat or following any distance. 1 foot is too much, 2 inches is too much, forget 6 feet if it gets inverted. So it's all about making sure that your batteries are in a liquid tight container, and that you cannot allow those batteries to move under any circumstances in the worst seas that you've ever imagined. And that's our objective for a battery box. So with that, I'm going to be asking my colleague if we've got a further question from anybody on the chat.
All right, Jeff, good morning, everyone, and thanks for joining us. We do have a question here from, Jeff, can you discuss the differences between using a single large deep cycle battery like a Group 31 versus multiple golf cart batteries? Is one better or worse?
Yeah.
And this is from Art.
All right, Art, thanks for your question. Great question, by the way. Yeah, not all batteries are the same at all. They're not. That's why they're different, and that's why they're different models. It's hard to beat a golf cart battery for a deep cycle application. In terms of a lead acid battery, a golf cart battery is hard to beat. Really hard. I mean, they were built for very, very tough situations, right? Batteries are going out for a day, getting completely hammered, coming back, getting recharged overnight, and then doing it all over again. So golf cart batteries are great deep cycle batteries. And given a choice between, let's say, 2 golf cart batteries in series to make a 12-volt battery, or 2 Group 31 batteries for deep cycle, hands down, I would go with golf carts. Group 31s are generally batteries. Of course, you can buy them for deep cycle, absolutely. But the construction of a golf cart is better. And so given a choice, from a cost perspective, you're not going to spend more money for this, by the way. So a golf cart battery is not more than a Group 31 battery. They're physically about the same volume, but slightly different dimensions. So if you can fit 2 golf cart batteries for a deep cycle battery, I would certainly recommend that. And that's where I would go. So great question.
All right, we have another question from Will. Do AGM batteries require any regular maintenance?
Yeah, so good question. So AGM battery, what does that stand for? It stands for absorbed glass mat battery, right? And it's basically another battery. It's a version of an SVR, seal valve regulated battery. So when you're buying a lead acid battery, you can buy it as flooded or as an SVR. An SVR has 2 popular choices. One is gel and the other one is AGM. So when it comes to AGM, the good news about them is they're liquid. There's no liquid in the battery, meaning they can't spill, and so you don't actually have to top off. There's no maintenance at all. The only thing that you would have to do, and like you should do with all our batteries, is you should always look at the terminals, move the terminal, a cable on the terminal sideways, not up and down, but sideways, and try to not go super hard, but enough that you're trying to move it. So that would be something you check to make sure you don't have a loose connection. So that's something you look for. And the other one is to look for corrosion at the battery post. So with an AGM battery, there's no need to top off the electrolyte. The only thing I would do is I would visually inspect the battery for corrosion and for loose connections on the battery post. So great question. Thanks for asking.
All right, we've got a lot of good battery questions this morning. We have one from Daniel. He says, obviously it's dependent on the boat and installation, but what is the most average battery size you see on sailing yachts?
Yeah, good question. I would say average sailboat is going to have, a lot of them from Europe have what are called Group 31 batteries. It's effectively a little bit like what would be in a truck. Let's say, for example, I have one of our service vehicles is a Mercedes-Benz Sprinter. We see them everywhere on the road, and a Mercedes-Benz Sprinter has a Group 31 battery, I think, on board. So it's about maybe 13 inches long, 7 inches wide, and about 9 inches high, going from memory. And the Group 31 battery is a very popular choice. The other one that you will see retrofitted a lot is the golf cart battery. So on a sailboat, you're mostly going to see Group 31s for house, and some boats have 4, 6, 8, 2, depending on the size, of course. And or what you'll see is after the boats left the factory, someone's increased the house battery bank size and is going to go with golf cart. The golf cart batteries are the same volume as a Group 31 battery, but they're basically a little shorter and they're taller. So it's the same volume, but different dimensions. But golf cart batteries, as I was saying earlier, are, I mean, they're hard to beat. They're tough. They're a workhorse. So golf cart batteries or Group 31 batteries. And for a starter battery on a sailboat, you're probably going to see a Group 24 or Group 27 battery size. So not too big, which is good because you got to bring those batteries down a companionway, most likely. And that's pretty hard to do. So the batteries are about 50 pounds, 25 kilograms in weight on average, which is heavy, but not unmanageable. So that's what most boats would have. Of course, there's always exceptions. Like my boat had, Catalina had 2 4D batteries on board. But most of us are changing those out to golf cart batteries. Yeah.
All right, another question. They've asked us to, if you could repeat the question so people
Oh, yeah,
hear
I will.
my voice.
All right, got it. Good one.
So here's a question. I want to leave my boat in the marina for a longer period of time with lithium batteries. Should it be connected to shore power or disconnected?
Okay, good question. So the question here is, this fellow boater has lithium batteries on board, and he's asking, what should I do when it comes to leaving my boat at the marina for extended periods of time? Should I leave my boat charging or not? With lithium, you generally don't, depending again on all the different manufacturers, they all have different BMSs, which changes obviously their requirements. But a lot of boaters are actually choosing not to leave the lithium battery completely full. So you want it full, but not too full. So yes, some people are actually disabling the chargers, but you got to make sure you don't have loads, right? So that the battery isn't constantly being discharged without a battery charger. And that's why most of us have battery chargers on our boat. Is not necessarily just to recharge the battery, but it's to run those loads when we're absent. Like what happens if the bilge pump comes on? What happens with your DC powered refrigerator? These are things that generally we're going to run on the boat, and they're going to effectively be run by a battery charger. So if you had a lithium battery on board and you wanted your refrigerator to still work, ideally, and some marine refrigerators have this, they have both AC powered and DC powered. So when you're connected to shore power, you could actually turn your battery charger off, and then you could also have your refrigerator powered by AC. So it's a hard one with lithium because every manufacturer, the BMS, is going to have different requirements, but many boaters are actually not leaving them connected all the time. Good question. All right, this is our first live event. I heard my mom's online, so I don't know if she's watching this.
Oh, the gentleman asked about the battery size.
Yeah.
Would also like to know what's the average size, like watts, amp hour.
Okay, good question.
Do,
Yeah.
an average sailing boat.
Yeah,
they have?
so the question from this fellow voter is, Jeff, what's the average size in amp hour battery bank? And when we're talking in the marine world for batteries, we're actually talking about this unit called an amp hour, which is different than an amp. Amp is current. It's the rate at which you're drawing anything, right? So you're drawing 5 amps. It's instantaneous. And amp hours is the amount of current you've drawn over a period of time, and that's called an amp hour. So we measure capacity in amp hours for batteries, and generally a Group 31 battery is around 110, 115 amp hours at 12 volts, and a golf cart battery is about 200, 240 amp hours at 6 volts. So they're effectively, again, same capacity. You need 2 of the golf carts at 220 in series to make 220 in 12. And you would have 2 Group 31s in parallel to make about a 220, 240 amp hour battery bank. So about 110 to 120 amp hours is the typical battery size capacity for a Group 31, or double that and minus the voltage in half for a golf cart. So golf carts are about 200 to 240. So good question. All right.
All right, this one is from North Slope. First-time boat owner has 2 batteries in parallel. I'm confused about whether to match the ACR and Blue Sea switch to the alternator output or the battery input.
Okay. All right. This is getting geeky. I love it. Well, it depends. Okay. So it's complicated. So first of all, your alternator on our boats, and this
Well,
is,
can you do the question?
yeah, the question. Thank you. Yeah, thanks. So the question is, I've got basically on my boat 2 batteries, and I'm adding a battery combiner, an ACR from Blue Seas, and I'm adding also a battery switch. And I'm thinking, should I be sizing my battery switch for my alternator or my starter loads? So, first of all, most of us, like 99.9999% of us, are going to have an alternator that is daisy chained to our starter solenoid. What does that mean? It means that the alternator output is effectively on a short wire, a few feet, less than a meter, is connected to the starter solenoid, and the starter solenoid is connected via an on-off battery switch or source selector battery switch to the battery. So when you're actually sizing that battery switch, the largest draw is effectively going to be, now remember, you actually would be disconnecting and connecting the alternator at the same time, right? Because the battery is connected to both the starter solenoid and the alternator. Effectively, one draws current, the other one pushes current. You're going to be sizing it for the starter. The starter is by far the largest amperage. Your alternator might be outputting 50 amps, might be putting 100. Okay, might be outputting 200. Okay, you got a crazy one, 250. Oh my God, it's a huge engine, 300. Your starter could easily draw 300, easily, no problem. So what you want to doing is sizing the battery switch for the larger of the 2 loads, which is going to be the starter circuit. So good question.
All right, from Victor. Can I use a 24-volt wind generator on a 12-volt system through an MPPT regulator?
Yeah, so I'm not super familiar with wind generators. Here in British Columbia, boaters that install them actually end up leaving to go offshore. Here in British Columbia and Alaska, our trees are giants and the anchorages are bomb-proof. So there's not a lot of wind in anchorages here. So most of us actually end up not having wind generators. Now, I'm not saying you don't want a wind generator, because in the Caribbean and a lot of places it's great. The terrain, the geography is different, right? Here, the mountains are giants. You can literally be in an anchorage and there's a 1,000-foot wall behind you. So a little bit different. But yes, like wind generators or solar, you can always have the controller is going to change. It's going to change the voltage output. Same thing with solar. Wind is another version of solar. And you can literally have a solar array that is outputting 48 volts, 30 volts, doesn't matter. And you're going to actually use your controller to actually change the output voltage from the charging source, in this case, a wind turbine, and actually bringing it onto your battery. So yes, you can actually change the charging voltage. And that's the purpose of these controllers. Because not only are they changing the voltage to a 12, but they're actually being more specific than that. They're actually going, oh, you should be bulk charging 14.4. Let's say you should be absorption voltage. Well, how long are you going to be in the absorption voltage? Oh, I should go down to float. So they're actually intelligent. They're not just simply taking whatever the input is and giving you 12, because 12 is not enough to charge a battery. You need a charging voltage. On a 12 volt, it would be potentially 14.4 for a period of time, and then absorption voltage for 14.4, and then flow. So yeah, you basically need to have a device in between your wind turbine and your batteries so that your batteries get the right charging voltage, including wind.
All right, a question from Jordan. Is looking for a bigger house capacity. He's wondering, would it be okay to remove a starter battery and increase the house bank?
Oh, Jordan's asking a question that is common. The question is, Jeff, I'm considering increasing my battery bank size, right, for the house. And I'm wondering, can I take the space that my engine battery takes and replace it with a bigger house battery bank size? I would advise against that. Listen, this is an opinion. There's no right or wrong here. So my opinion is as follows. I truly believe that your engine should have a dedicated battery to allow you to start your engine in all situations, in all cases. Meaning you should not ever have to worry that you've depleted your house battery and you're not going to be able to start your engine when you need to. So what I do is my philosophy, and I didn't invent this. I mean, was started way before my time, is to have basically what I consider a savings account, bank account. That is my engine battery. It only does engine starting. And like my car, I never worry about not being able to start my car because it's only meant to run loads when the engine is running, right? So it might start the engine, might run a fan blower, it might run the gauges, but it's only running the engine battery when I'm actually running the engine. The house, on the other hand, is different. The house is where you're running your water pump, your lights, your stereo, your refrigeration. And so by dividing and conquering, what you're doing is if ever, I'm not saying you don't care about what's happening in the house, but if ever you have an accident on your house and your house battery gets depleted for whatever reason, or it fails, then you can always have a redundant system, which is your engine battery to start the engine. So I'm a big proponent of divide and conquer, dedicated battery for engine, dedicated battery for house. And if you're increasing your house, just find more space for your house, but do not cannibalize your engine battery for a larger house battery bank. My opinion. All right. Good question. Thanks for asking.
A question from Tybor. If I have lithium for house and AGM for starter and thruster, I want to use a 12-volt DC-DC charger and external regulator. Should I charge the starter from the house or vice versa?
So the question is, for some of us that have lithium batteries on our house, AGM batteries for starter, where should the alternator output go? And honestly, that is a question that has no real answer. We are all sort of figuring this one out. There's pros and cons of each one. I'm not sure I'm going to be able to go on all of them. Certainly, the challenge is that these DC to DC charging converters that was brought up as a potential way of recharging one battery bank from the other with a different charge profile. The challenge is that a lithium battery is going to maybe be able to take a higher charge acceptance rate, right? Obviously, than an AGM. So if you've got a really large alternator, the DC to DC converters, charging converters, are not that big. There's none that you can buy for 200 amps or 300 amps. So we've certainly, in smaller installations, have the alternator recharge the house, not the house, the alternator recharge the AGM battery. And then what we do is a little bit like you suggested, we're putting multiple DC to DC charging circuits to recharge the lithium battery bank. And we're giving the lithium battery bank what it wants through these converters, right, that are actually specifically configured for lithium from recharging from an AGM battery. And then the way we do that is whenever the BMS on the lithium says no more, I can't take a charging voltage, the good news is your AGM battery never disconnects from the alternator. You're just effectively disconnecting your lithium battery from receiving a charge, but the alternator is always charged on your engine battery. That's the simplest way of doing it. And it's sort of our go-to, but it's not the only way. In some instances, we're also charging the house from a alternator, externally regulated, but generally we'll have a pretty sophisticated BMS that can actually talk to the external regulator and can actually stop the charging voltage from the alternator softly. So it doesn't actually disconnect the alternator, but it tells the alternator to stop charging. Tough question. Lots of different ways of doing this. Great question, though.
All right, a question from Cisco Kid. I have a 24-volt trolling motor. Is a 24-volt lithium battery better than two 12-volt lithium batteries?
Okay, so the question is it better to have this motor has a 24-volt trolling motor? And the question is it better to have two 12-volt lithium batteries or one 24-volt lithium battery? In this case, I would probably go with one 24-volt, especially that you can actually buy lithiums in 24. Probably I would go with one battery. Given that you can buy it in the amp hour capacity that you want, I would go with the 124. Ideally, one battery is always better than multiple. The challenge is that large battery banks can't be done in one battery, right? And that's why we built large battery banks it's like building a house with multiple small little bricks. And so it's how practical is it and how big is a battery bank get as we're adding more and more batteries. But if you can, and I know we can with lithium, buy a 24-volt battery, then I would go 24 over two 12s in series. Good question.
Okay, we'll do one more lithium, then we got some other. Motor vessel semi-retired. Can I charge my 12-volt lithium start battery from 24-volt lithium house battery through MPPT?
Can you repeat are both batteries 12 volts, by the way?
He just says, can I charge my 12-volt lead acid start battery
Okay.
from a 24-volt lithium house battery?
Yeah, so you could. Victron makes these DC to DC charging converters that actually not only drop down the charging voltage. So in this instance, you're going from a 24-volt lithium battery and you're going to a 12-volt AGM battery or lead acid battery. So yes, you can both modulate the voltage from 12 to 12, but make sure that 12 gets a charging voltage, or you can go from 24 to 12, and you can do that as well. And Victron has products for that are configurable to actually give the AGM battery exactly what it needs charging sort of charge profile. Yeah.
All right, a question from Jordan. Is it possible to run Firefly AGM batteries with lithium in a house bank together?
Yeah, so there's a lot of talk. The question is it possible to run Firefly and lithium together in one single house bank? There's a lot of talk about this on the internet right now. This is, in case you're watching this later on, this is February 21st, 2021. There's a lot of buzz about this right now. There's no field experience truly right now to extrapolate anything meaningful. What does that mean, in other words, is I'm always overly cautious with what comes to boats. Reliability to me and removing surprises is what I love to do. And I've read about it. I have never seen it, and I haven't seen it operate for years. So the question is, for now, certainly in the installations that we've done, we are not, so far, have not mixed and matched AGM batteries with lithium in a single bank. All our battery banks up to this point have always been, lithium battery banks separate from a starter bank or another bank. And we're not mixing different chemistries in parallel in one bank. Although I understand that there's arguments for that, the question is going to be, world of surprises. You don't want to be too much of an early adopter on a boat, I think, because the most important thing is reliability after safety. So we're going to have to figure out what are the problems with these sort of setups, and then over time learn from them, because early adopters don't care. I mean, they love that stuff, right? They're geeky. They're out there figuring it out for us. What really happens in the field? So good question. The jury's still out, so I don't know yet on that one.
All right, shifting a bit from batteries, we have a question. What is your solution, Jeff, to the problem of RFI on the VHF radio due to the inverter and charge control?
Yeah. Oh, that's a good question. So the question is what to do with RFI, radio frequency interference, on a VHF radio from an inverter and or charge controller. Yeah. What we normally end up doing is we end up having the inverter further away as much as possible because it's just high amperage. So we do that, making sure that all your devices, including the VHF radio and the solar controller and the inverter have all good chassis grounds. That's one thing. Some boaters are putting ferrites in. That happens as well. But probably proximity of the device is an issue. And by the way, this world of RF is a world unto itself. I am not a novice. I'm not even a Luddite. It's a world unto itself. I don't pretend to be an expert. Certainly does happen to us on some installs. It's pretty rare though, to be honest, nowadays. It's pretty rare. And there are experts in this field that are way above my pay grade. I don't encounter it as a problem that often, and hence I'm not that good at it. So it's a good question, but I don't feel that I know enough because we don't encounter it as a problem all that frequently.
All right, Peter is wondering, Jeff, what are your thoughts on digital switching? Is it the wave of the future?
Yeah, so the question is about digital switching. So what is digital switching? Digital switching is the ability to not have the switches be all located in one place. So you think about a current boat today or past boats, right? So you would have an AC or DC panel in a few places. You might have it at the helm, you might have it at the nav station, somewhere. And some DC panels are almost the size of fridges. And so basically what they do is the batteries, the AC come all to that panel, and then they distribute it like in our homes, and they go everywhere else. So it's basically a hub and spoke model. All the loads on the boat go back to the panel. With digital switching, what it does is it's actually distributed switching as well. So what they're doing is they're putting modules everywhere on the boat, and those modules can be switched remotely over network protocols, and some of them are actually using NVA 2000. So you can actually have a switch, for example, anywhere. It could be in a room, and it's controlling a module in another room if you wanted. And now the wires don't have to be all hub and spoke. You can actually have large buses going through the boat and then have individual wires connecting on that bus throughout the boat, and then you can control those loads without actually physically connecting or disconnecting the load in place, but remotely doing that with a digital switch. It's certainly going to be the future. It will happen. It's going to make our boats more complicated, which has good things and bad things to it. We've done them as OEM. We've built boats from scratch where we've done digital switching, and it's certainly getting popularity with some builders. It's harder to do or to get the benefit of that when your boat is already built. So there's not a lot of us doing digital or distributed switching on boats after the factory, because now all the wires are run. All the benefits of doing that are not, I'm not saying they're not there anymore, but there's less reason to do it once the boat is built. Certainly the builders are considering it. And when we've done boats from scratch, completely designed the boat from scratch, we've done digital or distributed switching. So it's not crazy. It's definitely going to happen, but it's going to take a long time, especially for the boats that are all in the market. Most of us are never going to change our switching, and it's not financially accessible for most of us. Yeah. Good question.
All right, our next question is from Jonathan. If you were building an electrical system from the ground up on a 30-foot sailboat, would you install 12-volt or 24-volt posting?
So the question is, if I was going to design from scratch a 30-foot sailboat, would I design it with 12 or 24? On a 30-foot sailboat, I would probably do 12. But at one point, if I was 40-foot sailboat, probably 24. Especially if I'm starting to have large loads. I think that the big dilemma for 12 to 24 to me is, when do we start having large loads? So large loads on your boat are thrusters, right? Windlass. Those would be reasons to do 24. An inverter, 24. Alternator, 24. It's not a load, but it's a good charging, right? So you want to minimize. So at one point, you could see yourself having a 30-foot boat with 24. It's just that the question is, how packed is that 30-foot boat going to be, right? So if you've got a 24, the good news is there's a lot of now what are called DC to DC power supply. So you can actually have a 24-volt battery bank, and we see this a lot in 15, 60-footers. They're running a bunch of 12-volt loads, not from a 12-volt battery, but from a DC to DC converter, taking 24 to 12. So past 40, certainly 50. If I was designing it from scratch, I would go with 24. The challenge is the starters. It's hard to change a starter when you retrofit a boat, and a lot of times maybe the starter can only be bought in 12, and then that makes it really complicated. You want to make sure your starter can be 24 as well, as much as possible, and so then everything is 24. Good question.
Let's try this question. Exactly how and where are suppressing ferrites supposed to be installed? How do they work?
Yeah.
You
Good.
can ask the question.
All right. The question is, where and how are ferrites supposed to be installed, and how do they work? I'm not going to answer how it works, to be honest. I had it explained to me when I was doing courses in university, and I sort of got it, but I didn't get it. So anybody who wants to chime in, I bet there's going to be some engineers online or geeks that know all about that. I don't. You'll see them sometimes installed. You saw that a lot in about 2005. Like, for example, Sea Talk from Raymer Marine would actually have Fireites on their Sea Talk cables. So they would do that. You saw them on older pieces of electronics equipment. You would see that as well. Nowadays, none of the packages from the manufacturers have ferrites. I don't see that on navigation equipment, don't see it on VHF equipment, don't see it on stereo equipment. They're not as prevalent as they used to be. And they used to be very close to the device. So you would actually install the ferrite in the past, really like within inches of the device. And you would normally have it looped along so that the ferrite wouldn't stop. And normally you'd have one loop on their ferrite. And that's about it. But that is way above my pay grade. Don't know that one. I can't even BS my way through that one. No way. Don't know. Good question. Really good question.
Here from Robin, sport fishing. Would two Firefly AGM batteries be a good setup for twin F-150 outboard engines charging at 50 amps?
Well, the question is, would two Firefly batteries, 12 volt, the Group 31s, be really good for these outboards, these 150 horsepower outboards? So the question doesn't ask, are they for starting or is this a backup, right? So if you're using your battery for starting, most of us are probably not going to choose a deep cycle battery for engine starting, right? A Firefly battery is meant really for deep cycle application. And so on on some boats, what you'll end up having is you'll have a dedicated starter battery, AGM, like a Group 31 North Star, for example, for starting the engine on a outboard, or Group 27. And then what you're going to have is you're going to have a house battery bank, maybe 2 golf carts, 2 Fireflies that are basically getting a charge from the alternator via the starter battery through a battery combiner or through what's called a DC to DC charging converter. So you can start a engine potentially with a Firefly, but they're around 700, 800 cold cranking amps. And you can buy a really Skookum Group 31 battery starter from North Star, and it's like 1,300 cold cranking amps. So in terms of punch, deep cycle battery will never be as good as a starter battery for starting the engine. So it really depends on the application. Good question.
So I have like 5 questions about lightning protection.
Yeah, the challenge with this, Missy, the question on light. Yeah, all right, go ahead.
No, just if you could say it out loud. There's some questions about lightning protection.
So lots of questions on lightning protection, folks. I have to say, here in the Pacific Northwest, we rarely get lightning storms. We just don't. It's really rare. It might happen I don't know. I might be aware of it once in a season. It's not something that we commonly deal with or people worry about. I know that it's a problem in other places around the world, like in the Florida and stuff like that. I just don't have experience in that world. I've only read about it. I've never installed a system for lightning strikes. So unfortunately on that subject, I just don't have real world experience. I would just be simply repeating what someone else has sort of studied or learned. And fortunately, I just don't have an opinion because I've never actually physically installed it or troubleshoot or improved it. It's just not something that happens in my world here. So sorry, don't have real answers to those questions. Okay, all right. Okay, all right.
Omar has a question regarding a Victron ArgoFET isolator. I have a Delco 10SI alternator with the 3-stage connections and 1 battery output. Would I need to connect or energize the terminal to the alternator?
Wow. Yeah, yeah. So I'm way too visual to be able to answer that in over. There's yeah. So let me show you what an Argo FET looks like. But the wiring diagram, I can't. That's super hard. So this is what we're talking about, right? An Argo FET is this device here. It's a device. It's a directional battery combiner, right? So what does that mean? Directional battery combiner, battery isolator allows one input, and the input is right here on this post right here. So right here, and that would come directly from your alternator output. So from the battery positive output of the alternator would go to here. And then the batteries, and this is 3 different batteries, could be connected. Now, each battery won't see each other. So it's a little bit like, I don't know. Sometimes I imagine the water hitting a sink divider and the water going on either side of a sink. So the faucet comes here, hits, either sink can't see each other. They're both getting water from the faucet, but neither sink is connected to one another. So they're going to charge obviously at different rates. Each battery is going to have, depending on where they are in the state of charge. But remember, this device does not modulate voltage. I get this a lot. This device does not modulate voltage, it just lets it through. So if you've got an AGM on one battery, you got a flooded on another, and then you have, I don't know, you have a lithium, this device does not take an alternator output and individually modify the voltage for every battery. The challenge is battery isolators are easy to install in about 70% of the cases, and they're actually mind-numbing installations on about 30%. So sometimes it's dead easy, sometimes it's freaking hard because of what the alternator needs to self-excite. So it's a real challenge, and I agree with your question. I wish I could answer it, but honestly, I need to see a diagram. I'd have to geek out, and it's not something that I can do on a YouTube channel like this. It's just way too hard. It's either trivial or freaking hard. So thanks for asking.
All right, Victor has a solar question. Other than smaller cable sizes, is there a benefit to having a higher voltage input for solar before the charge controller?
So the question is, are there any advantages other than minimizing voltage drop to have solar panels that have a higher input voltage before the controller? So the question is good because voltage drop is a real problem. But here in this case, the person asking the question says besides voltage drop. So realistically, the real reason why we'll put solar panels in series far away from the batteries and far away from the controller is to exactly do that, to increase the voltage so that the current stays low. Because as you increase voltage, the current is still the same. So every time you're adding a panel, you're just adding more voltage, but the current stays the same. Most solar panels only connect to gauge 10 wires. So you've got a limitation there. And also as a function, as you get higher and higher in the amperage on a gauge 10 wire, voltage drop is going to become an issue. So the real reason why we do it, which is the one you've excluded, but this is the reason why we do it, we actually go higher voltage into a solar controller for the purpose of offsetting voltage drop from a large solar array. And that's the reason we do it.
Yeah. All right, question from JB. I commented on your NMEA 2000 video. Great. Wondering about using plastic versus metal connectors, and can you mix them on the same backbone?
Question is for NMEA 2000, can you mix and match different connectors, plastic and metal, on the same backbone? So that's a really good question. And we get that a lot because not all connectors have metal ends. And the challenge, especially when you're pairing a metal to plastic, it's very possible that you're going to cross thread a metal to a plastic. It happens all the time and you can't control it. Most drops from most manufacturers that are included, a drop is, it can be up to 6 meters, 18 feet. And that's the distance between the appliance, the NMEA 2000 device, it's called a LEN. Between that device and the backbone can only be basically 6 meters or 18 feet. Now, most of the cables, when you're going to buy an AIS, you're going to buy a chart plotter, you're going to buy something, they're going to give you an NMEA 2000 drop cable, but they're going to give you probably a plastic cable for that. The ends are not going to be metallic. The only really ones that I see that are metallic are the ones that you buy specifically outside of a manufacturer. So for example, Meritron makes these really amazing NMEA 2000 tees, and they're metallic. I would avoid, for the backbone, to mix plastic to metal. I would try to keep it consistent and have metal everywhere. That being said, it's also hard because sometimes you're going to have a metal tee that's going to connect to a plastic drop. And even if you don't do it at the drop, you know, the device itself is probably not going to be metal. So at one point, you're mating between plastic and metal. So you can't really stop yourself from doing it. You're trying not to, but you're going to encounter it a lot. My only advice is when you're actually mating the two, the male and female threads together, go very slowly and make sure you have perfect alignment. And I've seen this where if you have a slight alignment, you're going to cross thread. And once you cross thread, it's going to be hard. Then even after you undo it and get it back, you might not have a perfect joint. So just be careful when mating NMEA 2000 connectors together.
All right, question from Jordan. My sailboat doesn't have a generator and I don't have space for it. What's your opinion on increasing alternator size on the engine to increase charging at 8?
Oh my God. Seriously? Are we friends? Question is, Jeff, I don't have a generator on my boat. And what's your thought of increasing the alternator size to recharge my batteries without a generator? Well, it's the way of the future. I mean, guaranteed. We've been doing this for over 10 years. We didn't invent it. Honestly, this is the play. Even power boaters that have generators, plural, are now looking at having high output alternators, external regulators. I'm having this conversation every day with across the whole gamut of boat owners. I'm talking sailboaters, power boaters with generators, having a high output alternator. And while you're underway, and a lot of this, remember, are not maxing out and punching out on our speed on our boats because we're trying to save fuel. So if you're going from A to B and you can get to B and have your batteries charged and not have to run your generator, that's actually desirable even for power boaters that have a generator. Saves generator runtime, and it just feels good that when you are motoring, you're actually not just getting there, but you're also recharging your batteries to get there. So huge fan of sizing high output alternators, and then up to a certain size, you got to go to serpentine belts. It gets complicated, of course, but listen, let me tell you, it is money well spent because now your engine is not only doing propulsion, but it's adequately recharging your house batteries or engine batteries while underway. So huge fan. It's not crazy. It's for sure the future. It's happening. I've done it on my boat for about 10, 12 years, done it on thousands of boats. And it's a great way to make sure you don't need a generator. Not all of us need a generator.
All right, Sunset Wingman.
Wow, love the name. Sunset Wingman. All right.
If you short ground the alternator, is it possible to fry engine sensors? Don't ask why. It's hard. Yeah, the question is what happens when you short an alternator to ground and can it fry engine sensors? It's hard for me to tell you what's going to happen on a car crash. That is hard. Honestly, I saw pictures just last week of a boat owner that actually disconnected his alternator while the engine was running. Unbeknownst to him, there was a problem with the wiring, how it was done, and he actually turned the battery switch and disconnected the alternator from the battery. The alternator looked like it had a mini explosion on it. It was unbelievable. So it's a pretty catastrophic situation. You can never, ever, ever disconnect your alternator from your batteries while it's charging via a switch. You just can't. You can, but it's like stopping a car with a wall. You're going to stop your car with a wall, but your car will not be the same. I don't believe I've heard of gauges blowing up because of that short, because I don't think they're in the path. The gauges are far away. They're connected to something separate. So I think it's only more going to damage the alternator than the gauges. But hey, listen, I haven't seen it all. Every day I'm learning new things. So if you've heard of this or you've got an experience to share, please put it down below and let us know. Personally, I don't think I've ever been asked to troubleshoot this problem, so I wouldn't worry about it. I think what would have happened is your alternator would have been seriously damaged. And maybe it can be repaired or simply replaced.
Okay, all right.
So here's a good question. Simple question, Jeff. What's the biggest issue you find when doing electrical audits? What mistakes do you see the most?
Yeah. All right, Nick. So the question from Nick is, what sort of are the biggest discoveries or problems that we encounter when we're doing these electrical audits aboard boats? So years ago, I came up with this concept of the electrical audit. I think it was probably 2009, and we've literally done probably I don't know what it is, 3,000, 4,000. It's and this is where I'm getting all my information, right? It's having been invited on all your boats and having seen all the problems that we share collectively. The probably the biggest problem is people that don't know what they're doing. Again, it's not their fault, and they're taking shortcuts. Um, so generally, what I'm looking for on a boat, when I'm looking at a boat, I'm looking for problems. I'm looking for anything that's out of place. I'm looking for telltale signs. I'm looking for new work. I'm looking for sloppy work, and that's okay because sloppy work generally means that they're out of time, which is bad with electrical. It's a perfectionist business, and they might not know why they need to make it look neat. And so I'm looking for that. So the first trick, what I do when I come in on a boat, I'm scanning. I'm almost like a robot, and I'm looking for anything that differs from the quality of work beneath it. Right? If I'm looking at wires that are out of bundles, wires that are loose, wires that are just not following the chases, anything like that tells me right away, I'm like, aha, we've got someone that decided didn't have enough time to do it properly. Now let's look at what else they took as taking shortcuts. So the first thing to look for is your boat. You've got what the builder did, which is generally, honestly, 99% of the time great. It is. And then you're looking at what happened. What is the previous installer did or the previous boat owner do on your boat? And now you're looking for these signs of taking shortcuts. The next one is probably the biggest issue is everything bypassing the panel or the switches. Most people, unfortunately, are overwhelmed with this electrical. Not are their fault. I was too when I bought my boat. Even though I had studied technical in school, did an applied sciences degree, that was not enough to prepare me for how hard boat ownership was. And so generally, most people bypass switches. And so they're going, hey, you know what? I don't understand all this confusing part. If I go right to the battery, bam, I'm done. I've got 12 volts. And what they're doing is they're basically just doing always hot connections, right? They can't be turned off. They're always on. They're not fused. And so fusing becomes a real issue because remember, any load will work without a fuse. The fuse is not there to make the appliance work. It's to make both the appliance and the wire connected to the unit safe in the event of overloading, either through a dead short or a problem within the unit. And so those would be the things I would look for on an electrical audit the most.
All right, so I got 3 or 4 questions that I'm combining now.
Okay.
How large can an alternator be? And how do you size those high output alternators?
Okay. Question is, how large can an alternator be, and how do you go about sizing a high output alternator? So first of all, there's limitations about your engine, right? So you don't do what you want, you do what you can. So that's the first rule is this is not completely a blank wall that you can just do whatever you want. First, you got to figure out, what is the drive pulley system on that alternator? Is it going to be single V belt, dual V belt, or serpentine? That's first thing. The ability for you to move something is going to depend on those belts. Generally, a single V belt is up to 90 amp alternator, period, 12 volts. And after that, you're going to need dual V belt or even better, serpentine. Some manufacturers like Balmar and other companies are going to have kits to make serpentine pulley kits that are going to go on the front of the engine so that you can actually drive a larger and larger alternator. Once you leave 90 amp single V belt, then you're going to need dual V belt or even better, serpentine kit. So then you're going to have to look, is my engine, does it have a kit made for it so that I can actually put serpentine? I did that on my boat. I had a 30 horsepower universal M35 engine A, and I had a 9, like my boat came with probably a 55 amp alternator, and I changed it now to about a 210 amp alternator, and I have a serpentine kit. Now, that's all what you can do, but the question is, what can your batteries take as a charge acceptance rate? It's irrelevant to have a crazy alternator and have no batteries to put it in. Lithium pretty much can take capacity 3 times of capacity, so there's no limiting factor with lithium. Your alternator is just going to do everything it can, but the lithium pretty much can handle anything. The next is going to be Fireflies. Fireflies can easily take about 0.4 C, easily. even up to 1 C of capacity. After that, you're going to have AGM, which is about 20% of C, and then you're going to have flooded lead acid battery, which is about 10-15%. So for instance, if you've got a 2 golf cart batteries on board, 220 amp hours, right, in series, right, the max charge rate of those batteries is realistically around 50 amp hours tops, right, or 50 amps. So don't waste your time putting a 500 amp alternator to recharge a battery bank that can't take it, because they all have their ability to take a charge rate. So all of those factors come into play when actually sizing a high output alternator for your boat. It's pretty tricky, takes time. Don't be impatient. It's a world of mechanical and electrical coming together, so it can be a little bit frustrating if you expected it to be trivial. Yeah, good question. All right, do we have another time, or are we?
Time for 2 quick ones.
All right.
So let's try this one from Russ.
Okay.
We're installing a large solar array.
Yeah.
Should we expect issues with alternator self-exciting when underway?
Oh, that's a good question. The question from Russ is, we're installing a large solar array, and while underway, when we're actually running our engines, will my alternator cut off, stop working intentionally because it sees that the charging voltage of the battery is high enough, and the alternator says, you know what, I don't need to work. I don't work. And the problem with that is fine for the alternator not needing to work. The challenge is a lot of us have the tachometer output come not from the engine, but actually come from the alternator. So yes, it is possible. Happened on my boat, of course. I installed a large solar array, and absolutely, my alternator actually stops charging, and I lose my tack because the external regulator says I don't need to do anything. Your batteries are full because I have a large solar array. So what I end up doing is to sort of do a workaround that, I just go down and I turn some loads. I basically increase the loads so that the alternator says, hey, by the way, we're going a little bit slightly negative. You know, I need to do something. And so I'll turn on some lights. I might turn on the inverter and, you know, maybe leave an appliance on or something. And basically what I'm doing is I'm creating a load so the alternator says I should help that too. And that's how we go around the workaround with the alternator deciding to disable itself and potentially losing your tachometer output. But if your batteries are completely empty, right, it doesn't matter that your solar is charging. It's all hands on deck. Like you could have your solar charging, you can have your wind turbine, you can have a methanol fuel cell, you can have your alternator, you can have all these things charging. And if the batteries are really empty, you're not going to get to that set point voltage right away. And it's going to take time. So all of them are working together. And as you get closer and closer to the end, various loads are going to be pulling off. Yeah. Okay.
All right, so closing up our last question.
Okay.
Someone wants to know from Finland how they would get involved with you to design an electrical system.
All right, so the question is, how do we involve Pacific Yacht System to doing consultation or design? There's a whole section on our website. So if you go to www.pysystems.ca, one of the top level is a sort of past designs. We probably do right now, I would say, this year alone, we're probably going to do over 500 electrical designs with boat builders, do-it-yourselfers. Doesn't matter. People that just want to have someone in their court helping them out, giving them advice. And so the best way is go on our webpage, see the documentation that's there about the whole process. And then there's actually a little form on the side, and you can actually fill it out and contact us. And then we'll reach out and we'll talk about how we can help you be on your side, helping you figure out what's the best electrical system for your boat. So that's really popular. And honestly, it keeps a few of our engineers really busy working on that. And it's pretty awesome. So yeah, good question. Thank you. All right. And so, by the way, this is our first YouTube live. I can't tell you how nerve-wracking this was for all of us. We didn't know we were going to be able to pull it off. We can pull electrical on a boat, but can we pull electrical or doing a YouTube live? We did it. Thanks for everyone for joining us. Honestly, as you can see, I've been answering questions for an hour, and I can do this, no joke, for 24 hours. I think at one point I might just do a marathon, see how long I can last until I fall. I find this absolutely energizing. Love it. Thanks for everyone for actually caring about your electrical, making it better, making it safer, making it reliable. And if you haven't subscribed to our channel, please subscribe. Actually, it sounds geeky, but it encourages everyone here at the office to keep posting these things, as we're not getting paid to do any of this. We're just doing it because we love boating. We're boaters too, and we're trying to make everyone's experience on the water safer and reliable. All right. So thanks for chiming in, and we're going to do this again. Thank you.